Good day, everyone. We are the Rabat Solar Team, a group of 12 Moroccan engineering students from the National School of Mines of Rabat, whose mission is to promote solar energy by making eco-friendly solar-powered cars and honorably represent Morocco in the most prestigious competitions in the world, such as the Moroccan Solar Race Challenge in Morocco and the United Solar Challenge in Egypt. Ever since its creation in 2014, our team managed to design and build 4 solar-powered cars: Eleadora 2, the one in the picture, which is our latest invention and whose name means a gift from the sun, had seen the light in 2019. Regarding our solar panels, we are using SunPower's third generation Maxon solar cells owing to their strength, durability, and efficiency. The following figure is a technical drawing of Eleadora 2's solar cells. The electrical characteristic and main reason of our choice could be summarized in the next table, which is primary efficiency. Our car was constructed following specific international competitions regulation, which requires, for example, approximately 4 square meters of solar panels, and each cell occupies 15.625 square millimeters, a total of 256 cells. The solar panels in our Eleadora 2 are placed as follows. Moving to our power tracking technique, we are using the MPPT Nano manufactured by Nomura code-type output 2337 volts, which is specially dedicated to solar race cars. And since the battery voltage varies, we wanted to choose the number of MPPT in series in order to make the solar panels charge our batteries regardless of their charge state. So we used 4 ones in series in each line, and since we got 2 lines in parallel, that makes 8 MPPTs in total. The table sums up the entire wiring system for the both lines. It shows which block is linked to which MPPT in which line and all the other information on the number of cells in each block. Our energy storage system was also designed to respond to the competition rules, which requires the installation of a safety system in case of failure and also fixes the weights of the battery cells and many more. Here's an extract from the technical regulations that kind of determines the total allowable cells mass in kilogram. As mentioned before, the weight is one of the biggest challenges, so we opted for a technology that offers a maximum gravimetric energy density that lasts long and that provides a higher voltage. It is the lithium-ion batteries. The weight is determined in our case for 20 kg. However, its main disadvantage is the need for a proper management system to guarantee safety, otherwise the unmanaged cells can catch fire and explode. And here steps in the battery management system. Taking this into consideration, performance, capacity, the protection, and ability to manage the high power circuits based on the battery need, we are using the Orion 2 size BMS36. The box for assembly is made of slatted wood and the plates on the left and right are made of the red wood to be able to withstand 20-gram acceleration. And here is Eleadora 2's main circuit, and this is our battery pack. Moving on to our mechanic aspects, our car's chassis was designed in order to minimize the energy consumed due to mechanic frictions. So we built it using 1661 aluminum, which is characterized by its rigidity and its low density. Its weight is 17 kg. Our suspension system is made entirely of aluminum 7074 so that we could benefit from its lightweight characteristic. And last but not least, the shell, which is often mistaken for a chip's shell, was designed to significantly reduce the aerodynamic frictions, and was made of carbon fibers to keep it as light as possible and of course as safe as possible from the regulations view. One of the main keys to win a race is to establish a good strategy. So, our strategist's main mission is to analyze the speed of the solar car so that it could reach the finish line as soon as possible within the limits of the battery and actually give the driver the areas in which he could speed and others where he should slow down. The dashboard is important for the drivers as well, as it controls the panel of the solar car. It provides the driver with the necessary data on the speed, the power, the current, etc. The following sheet highlights the importance of optimizing the design in terms of the car speed and time saving. As for the telemetry, we are using ZoomLink, which is an embedded system used in military application due to its 10-mile range. Thank you.